Welcome to 2021, and I think it's time we finally got some control. Crap pun aside, this is the controller for my PyWaz robot, McVehicle Prime. The controller itself is going to be used in more projects going forward as well. The rest of it is actually a Raspberry Pi. You can see that's in a custom case with the full touchscreen. I've used that in the past with the robot operating system to actually control the robot, and that'll be what I'll be working on next week. Previously, when I built this back for PyWaz 2020, the Teensy that was in here was running ROS serial, ROS Arduino specifically. And the idea was that it was creating the messages sent across to the robot to directly drive it. But to make it a bit more, not easier exactly, but versatile, that's the word I'm looking for, I thought I would instead actually turn this into a custom joystick so that it shows itself as a human interface device, a standard joystick to any computer it gets plugged into. Wonderfully, the Teensy, I've got a Teensy 4.0 in here, just there, supports this functionality out of the box, which is absolutely fantastic. And yeah, with the Teensy 4, it gives us just enough pins for everything we need. The reasoning behind this is that the ROS Arduino support for ROS2 is in its very early state, and it's certainly not as fleshed out as it is for ROS, which it works. And to that end, I thought if I turn these into normal joysticks, then the Pi can listen for those events, and that is a very performant library, the EVDev library, and the Pi can do the transformation. It won't be that much of an overhead, and it just gives us that flexibility, and it makes it a lot easier to develop as well. So what we can see here, and I will switch to the desktop as well. Okay, so on Windows at least, it's really easy to test a joystick or any game input device. If you go to Start and Run, or in a command prompt type joy.cpl, it will actually take you directly to the control panel dialog for game controllers. If you click on Properties, I'll drag that over slightly so we can actually see it this time, you'll see a dialog showing the state of the joystick that's connected. So as you can see, in this case, we have X and Y, and rotating the left stick gives us a Z axis. You get Z rotation when you're doing the X axis on the second controller. The right slider is rotation on that one, and up and down is left slider. Now, this is using the default USB device descriptor for a joystick that comes with the Teensy, which is why this stick appears as a bunch of sliders rather than as another axis. Well, I mean, they're all axes. But at some point, I'll try and dig in and actually get it so you have two analog axes, as you'd see from plugging an Xbox controller into it, for example, but this does for now. So for the rest of it, we have these switches along here. These were actually scavenged from an old RC remote controller, so they're really nice and chunky. So we have just a normal switch here, and you'll see button 1 on the screen, switch on and off. Up is off, down is on. That's just the convention I went with. You can do whatever you want in your code. So yeah, we've got a on-off toggle for button 1, on-off toggle for button 2, and this, but the third one along is actually, it has two states, up and down and middle. So down switches on button 3, center is both of them off, and up switches on button 4. So it's just like if you've got 3 different speed modes, for example, you can use that switch. Next on is just another single throw switch. We then have the encoder, which I'll get back to in a second, and this last one is a really nice spring-loaded trigger, spring-loaded switch even. So the idea is when I'm doing the doing anything that needs like a payload releasing or firing the Nerf gun on the robot, I can just press that and it'll just trigger. These joysticks also have buttons on the top, so they're mapped to 7 and 8. And then finally we have the encoder. Now this is quite cool. I'll put a link in the description for this. I got it from Cool Components, and it's a rotary encoder with a click button and an RGB LED. So first off, if we press that, you'll actually see button 9 on the test screen light up, but you'll also see the color of the LED actually changes. Now this is just handled on the Teensy at the minute, so these colors don't mean anything other than you've pressed the button. It's mostly just for this video so you can see what's going on. And if you rotate the button, you'll see it's currently changing brightness, and again that maps to the colors as well. This, as you can see from the screen, the rotary encoder is currently locked to the point of view hat. Now this point of view hat is it's literally I think it was an old 4-way switch. So you had up, down, left and right, and then obviously up, right, down, left, up, left. So it's got a limited number of directions in which it can point. They're all at 45-degree increments. I would have preferred that to be able to do like 0 to 360, because then it's just like a proper dial, as it were. But as you can see on the user interface there, as this is rotated, the arrow on the point of view hat updates as well. There is a center value, so this will switch off, but because I'm using this as a dial, it just does, it stops back at 0. What I'm going to do in the future is, and as you can see over here, serial keyboard mouse joystick. What I want to do is have it so that if you establish a serial connection, you can actually get the raw encoder value out there, so you can actually have 0 to 100 or just whatever numbers you want it to be, and that the Pi itself will be able to send color values or states to it so that it'll actually override the defaults. For now at least, it's just doing the standard color change, and I'm making a hash of framing this. But the proof is proven. It does work, and yeah, I also tidied up the wiring a great deal. So I got a cheap crimping kit off eBay, I think it was. So you can see here I've got a Perma Proto board, or a clone thereof, and it's got these plug sockets on here, and that means I can actually, say if I needed to swap out the rotary encoder, I can do that. Same with these, and the rest of the switches are just in a bank. So it's not as individual as it could be, but it's for a second attempt. I'm really proud of this. So yeah, that is the current state of the controller. It's now an incredibly overly complicated game controller, but that's where we want to be. It gives us lots of options for the future, and really do like the trunky switches. So yeah, the tactile feel of them, like Tom Paris in Voyager, Delta Flyer had to have those old school toggles, which I can completely relate to. So that is the controller as it stands. Now, from a previous video, you'll see that I've already had it so that I've got code that runs on here on the Raspberry Pi, currently a Pi 4 actually, that's used an Xbox controller. So taking that and tweaking it so that it just listens to events from the anything controller instead, it's not going to be a problem. So yeah, that's going to be some of next week's work. Other things I've also been working on is, oh, come on MFP. I've tidied up his rear end considerably, so I've actually got some decent cable ties now on there. It's a lot more orderly. I've also replaced all of the old wiring that was from my classic Mini or scavenged computer PSUs. I replaced it with some new silicone coated wire, so this is a lot more flexible, and we don't get the issue where if he tips his head back, his head actually popped off, which wasn't ideal. So all of the wiring for his head, so for the motors and for the power control, has been redone. I've also added a fan cover on the back because it didn't have one. That's one of his eyes. It kind of fell off, so I've just been leaving it inside his skull, because you know what is our skulls for if not storage. And other things I've been working on. Yeah, as you can see, just tidying up the wiring underneath as well. So before, these were just loose because I never really got around to doing anything else with it. Probably a bunch of other little things I've been doing on there as well, but those are the headline items. And yeah, the next up will be getting more of the controller working and kind of integrating it all together. Now, for one thing, if you've watched this long, thank you. And yeah, as some of you all know, I recently quit my job because this is the ideal time to do that. So I've actually set up Neve Engineering as a company, and the idea is I'll be spending the next few months in the run-up to Pi Wars working on this robot and associated projects full-time. This will give me loads more time to actually learn all of these concepts properly and give the robot the attention it deserves. But not only that, and kind of help me attain a life goal, which is become a robotics engineer. And yeah, that's kind of happening at the minute. So ideally, I'd be able to get to the point where this channel is actually able to bring in enough funds to keep this going. I'm basically using my savings at the minute, and I've got other plans to actually develop the business to bring other revenue streams online, I think is the phrase that is used. But they're not done yet. And yeah, but in the first instance, if you're able to go over to my Patreon, which is patreon.com/NeveEng, same as this channel and all of my other media profiles, because I got lucky with those, and you can support me from £1 a month. Now, that's not going to... basically, if you go for £5 and above, those two tiers, you get early access to the videos and a few other perks, which as the audience grows, will become more useful, like giving feedback and live streams and things like that. But everything I create will still be open source. So if you support me or not, it'd be great if you did. If you're not able to, don't worry about it. Times are tough, to say the least. It just means that you won't get early access. So you'll have to wait a couple of days, which isn't exactly a big deal. And I know I'm talking you out of giving me money here, but it does help a great deal. So I've also already got enough kind of banked from my early supporters that I should be able to build a new set of arms for the robot using servos with analog feedback, so I can actually get set and get the position of the arms, for example. So it's things like that which will have a direct help on this project and others alongside. So if you are able to help, that would be great. If you're not able to help financially, then just like the video, share it, all the usual things you end up doing with YouTube videos. You know, we've got to feed the beast, which is the YouTube algorithm, so those things do help. But other than that, yeah, I'm hoping to now do a video a week. It'll be mostly things like this, which is kind of like a work log of the week so far. And every now and then when I get to a big point on a project, I'll do a wrap-up video specific to that project. So yeah, stay tuned for more, and let's see what the year brings us. Bye for now.